In this video, we will explain about SIC Assembly Language Programming. So, this is the SIC machine architecture. We have 5 registers with each 24 bits. They are A, X, L, PC and SW. And these are the number corresponding to each of these register that can be used during our assembly process. So 0 is the number corresponding to A register, and 1 is the number corresponding to X register, 2 corresponding to L, 8 corresponds to PC, 9 corresponds to status word register. And A is our accumulator used for arithmetic operation. X is the index register used for addressing, that is the indexed addressing mode, and L is linkage register. The jump to subroutine JSub instruction stores the return address in this register, that is associated with the subroutine call and return. Then PC, that is the program counter, contains the address of the next instruction to be fetched for execution, and SW, that is a status word that contains a variety of information including condition code, or that is actually a flag register. Then next we can start how to write assembly language program with the SIC machine architecture. In any assembly language programming, there are 2 types of statements. One is instructions, and another type of statement, assembler directives. Assembler directives. So first one is instructions. Instructions are statements. Corresponding to these statements, machine code will be generated. So in this case, these are instructions LDA 5. This is one instruction, this is another instruction, this is another instruction, like that. Then second type is assembler directives. These assembler directives are actually statements. They will direct the assembler during assembly process. That is memory allocation, then start of the program, like that. Corresponding to these statements, there will be no machine code will be generated. These are assembler directives. So in this program, this reserve word, byte, reserve byte, they are assembler directives. So before explaining this program, we can first explain some of the memory allocation directives. One is reserve word directive. This is actually reserve word directive. So this directive is used to create a memory variable or to reserve a word within the memory. So for example, if you are using a statement like this, num reserve word 2, this indicates this will reserve 2 words of memory within the memory, and that will be associated with the label num. Okay. So if you are considering a memory like this, assume that this is our memory, and this statement will allocate 2 words. In the case of SIC, the size of one word is 24 bits or 3 bytes. So this corresponds to 1 word and 3 more bytes, second word. So assume that the memory address are 200, 201, 202, 203, 204 and 205. So two words will be reserved and the name or label num will be associated with it. That is the purpose of the reserve word. Similarly, another directive is reserve byte. This is used for reserving one byte. Reserve byte. This directive is used for reserving one byte of storage. Okay. For example, if you are using ch reserve byte, then 1, assume that 1, then this will allocate, for example, here 250, assume this is 250 address, so this will be associated with this label ch, so 1 byte will be allocated. That is the reserve byte. That's about the reserve word and reserve byte assembler directives. These are used for allocating storage for variables. Storage for variables. Next we have to explain about the assembler directives word and byte. Word and byte directives. So these two directives are used for creating memory constants, because in the case of SIC there is no support for immediate addressing mode, so we cannot directly use constants within our instruction. So we have to use constants. We need constant. So for that purpose, what we will do, we create memory constants. For that purpose, we can use the word and byte directive. First we can consider the word directive. Word. For example, 5 word 5. So this will create a memory constant with value 5 and label FIVE or 5. Okay. Assume that this is our 5. This is 2. Okay, 258, 259, 25A. For just an assumption, these are the memory addresses, and so this will be 5 and a value of 000005 will be stored here. So this will create a memory constant with this value 5 and a label 5. Starting address will be 258. That's about the word directive. Then next, what is byte directive? Byte directive. This byte directive is used to create a byte constant. For example, ch byte some a. So this will create a byte constant, that is single byte constant with value ASCII value a and label ch. We can give another ch one, for example, just for difference we can use, instead of ch we can use some other name. Okay, I am using a name code for just for differentiate between this ch and this one. Assume that this is 100. This will create code with this value a. So a byte constant can be created with this directive byte. That's about the byte directive. So these are the some common directive that we will use in our SIC programs. Okay.